The fix starts with an observation about asymmetry. Generating a token is expensive because the model must produce a full probability distribution from scratch. It has zero information about the next token until the forward pass completes. Every parameter in the model gets loaded, multiplied, and written back for that single token. But verifying a token is cheap. If someone hands you 5 candidate tokens and asks, would you have produced these? You can check them in a batch, and a batch of 5 costs roughly the same as generating one. During verification, the 5 candidate tokens are already known. They can be laid out as 5 positions in a sequence and processed together through the transformer, the same way the model handles 5 tokens of input during prefill. The weight matrices get loaded from memory once, and all 5 candidates ride the same memory fetch. The attention computation over 5 additional positions is trivially small compared to attending over the full context. During generation, each token requires its own separate full load of the model weights from memory. During verification, 5 tokens share one load. That is the asymmetry that speculative decoding exploits. The setup uses 2 models. The draft model is small a fraction of the target model's parameters. It is fast precisely because it is small. Fewer parameters means fewer bytes to stream from memory per forward pass, which means each token costs a fraction of the time and a fraction of the energy. The draft model races ahead and generates a window of candidate tokens quickly. In GLM5.2, that window is 5 tokens wide, expanded from 3 in earlier architectures. The draft model produces 5 guesses in roughly the time it takes the target model to produce one. Then the target model verifies the entire window in a single forward pass. It runs one pass with all 5 candidates included as input, and at each position, it checks whether its own distribution agrees with the draft model's choice. If all 5 candidates pass, you just got 5 tokens for the cost of one target model forward pass plus one cheap draft model window. Throughput multiplies by 5. If the verification finds a disagreement at position 3, you keep positions 1 and 2, discard 3 through 5. Sample the correct token from the target model's distribution at position 3 and restart the draft model from there. You never emit a token the target model would not have produced. The critical metric is acceptance length, the average number of consecutive draft tokens the target model approves before finding a mistake. Longer acceptance means more tokens per verification pass. More tokens per pass means higher throughput. Every fraction of a token of improvement in acceptance length translates directly into real-world serving speed across every generation step the model executes. GLM5.2's baseline acceptance length is 4.56 out of a 5-token window. The draft model guesses right most of the time, but the gap between most of the time and nearly all of the time is where the real engineering happens.